Hello, everybody. It is Mr. Cunningham going for the review for the second test for Unit 4, Part Due. The dates are going to be different for different groups of people, so pay attention to whether your class is taking the test on Friday or Monday. Could be either. And also stick around to the end of this video because we're going to have a lively discussion about the slang word merch. Where does it come from? Why do we say it? If you're wondering these same things as I was the other day, then stick around. But before we do that, now I'm just speaking to my class right now. Let me get these pesky pens out of the way as I share my screen. We are, oh, don't share, get out of here. All right, make it a slideshow. Oop, I need my pen working. Come on, people. There it is. Okay, so my class, if you are a freshman, not many of you, a sophomore, quite a bit of you, and seniors, mixed them out. Your test is on Friday, as planned. Juniors who have class promo days, and are like, oh no, I'm going to take my test. Why is Mr. Cunningham do this? Your test, a different version of the test, but essentially the exact same test, but with a different version of it. Hint, hint. Study. Don't just look at an old version, everybody. Your test will be on Monday, so it shouldn't be too big of a disruption. If you are out of class for that, you have that. If you're just like, oh, I'll just act like a junior and not come to class, don't do that. Anywho, let's get to the math, shall we? There we go. Okay, let's look at this first one. I gotta move my face. I know it just looks like it's in one place to you guys, but it's all over the place for me. Hold the jokes about my face being all over the place. All right, so these equations, there is tough things about them, right? Mainly logs and exponents, but just treat them how we've treated regular equations in the past. If I was multiplying 4 by something in old equations, the way I would get rid of that 4 is to divide both sides by 4. And that doesn't change just because I got some exponents hanging around. So now I have 10 to the power of x plus 2 equals for d,000 divided by 4, which is 10,000. Now, previous knowledge of exponents might just help you. You might be able to look at this and be like, hey, 10 to the power of 4 is 10,000. So x plus 2 is 10,000. So what plus 2 is 4? If everything I just said just totally confused you, well, then just go through the process of using your logs, which is to rearrange this. So log, since it's a base 10, I don't need to give it a base. I can just say log, which indicates a base 10, argument 10,000, which I honestly, thank you, Miss Royer, for reminding me that that is the term for that. Okay, so I've just rearranged this equation, and now I have my exponent on the bottom. Log 10,000. If you just hit the log button, you don't need to write base 10. You just write log 10,000, and you should get 4. And if 4 equals x plus 2, then we have a one-step equation. Take 2 away from both sides, and you have 2 equals x. Okay, so what I was saying before, right? 10 to the power of 4 is 10,000, right? So if x goes into here, 2 plus 2 is 4. 10 to the power of 4 is 10,000. 10,000 times 4 is 40,000. So I'm just saying, all I'm saying is that reminding yourself of some entry level exponents that you've done, 10 to the power of stuff, 2 to the power of stuff, that sort of thing can benefit you if you're struggling about why am I using these logs. Like, think about what is going on there. Okay, I'm going to rewrite this just so I have more room. 3 times 2 to the power of y equals 24. Divide both sides by 3 because that is one of the things that's keeping this from being alone. So I have dividing by 3 cancels out. 24 divided by 3 is 8. Now, right here, if people are scrambling, I need to do log base 2 to figure this out. And I don't have the chart of log base 2. And I don't have the calculator that goes there. Oh, no. Well, I don't need you to go crazy here. All I need you to do is think 2 to the power of what is 8. And even if that doesn't click, if you're not thinking to yourself, hey, 2 to the power of 3 is 8, which it is, well, then just go through the process. 2 to the power of 1, 2, 2 to the power of 2, aka 2 times 2, 4. 2 to the power of 3, which is 2 times 2 times 2, 8. So that tells me that y equals 3. All right. Can we switch colors for each problem? Sure. Why not? Okay. Here we don't have to divide. We've already got 10 alone, so we can just log right away, as Ren and Stimpy would say. This is brought to you by log. What goes downstairs in singles or pairs, run over your neighbor's dog. It's good for a snack if it's on your back. Log, log, log. It's log, log. It's big, it's heavy, it's wood. Log, log. It's better than bad. It's good. Everyone needs a log. Log, log, log. Log from Blammo. Look it up, Ren and Stimpy. Log. Ask your parents. Ren and Stimpy log. What does that mean? They might look at you like, I can't believe your teacher is talking about that. Let's get you out of that school. Just joking. We love it. Okay, so log 810, log base 10 of 810, right? Argument 810 is 2.91. That gives me 3n. It came out of the exponent there. I don't want 3n. I want to divide by 3. And then we have 2.91 divided by 3, roughly 0.97. Okay. For some reason, that red color, it's not inviting. Okay, 24 e to the power of 0.4. Oh no, 0.4, aka 40%. How can I use 0.4? There's a decimal there. It's different. Don't discriminate against numbers with decimals. Just like you and me. Okay, divide both sides by 24. Once you divide by 24, you have a problem that now involves E. Oh no, E. What does E mean? E means that we are continuously multiplying by set number 2.718. But really, what it means for the context of what we're doing, a lot of people ask me how many decimals to go there. This is a clean decimal, so go to 3. I'd say going to 3 is a pretty safe bet, usually. And then like round to 2 if you're dealing with money, stuff like that. Okay, so E, what we're essentially doing log with a base of E, which we learned in class is a natural log. So we need the natural log of 7.125. And that gives us 0.4 t, the natural log of 7.125. I'm rounding here, and hopefully don't round until the very end. Your calculator, I would say just use the value, transfer it down. But it was roughly 1.96 equals 0.4 t. Now, if that just said 4t, I would divide both sides by 4. Well, it says 0.4 t. So I'll divide by 0.4, just the same way as I would divide by a whole number. Okay. And that I think without rounding earlier, anyway, you should get somewhere close to 4.91. And then don't call 911 because it's not an emergency. You got the right answer. Okay, in this problem, what does the 9 represent? It's the starting population of the bacteria. We have 9 bacteria, right? We have 9,000 bacteria. Okay, so the starting population of bacteria is 9,000. Or actually, it didn't say square area or anything. We have in other problems, so we'll just say is 9,000, like there are 9,000 bacteria. What does the 0.3 represent in context? The context of this is we're growing, okay? And we're growing continuously. That's why we're using E. At what rate? We're growing 0.3 is like saying 30%. So basically, this is 30% growth. And yes, you need to say 30% growth. Can't just say 0.3. Okay, we need to tell me, stalling because my pen stopped working there for a minute, that it is a percentage growth and that growth is happening continuously. Continuously. I think I even spelled continuously there. Okay, after how many hours will there be 18,000 bacteria? So we're essentially saying, okay, if we start with 9,000 and we grow at this rate, 30% per hour, when will we have 18? And then write 18,000. No, don't write 18,000. If 9,000 is represented with a 9, then 18,000 needs to be represented with a 18. Okay, so you got to apply it to both sets. If you decide to write 18,000, not the end of the world. That just means you need to, instead of writing 9, write 9,000. Okay, they need to match. Okay, so divide both sides by 9. And now we have e to the power of 0.3 h equals 18 divided by 9 is 2. And now I'm in a position, I'm going to rewrite it because on my end, I don't have a lot of room at the bottom. So I have e to the power of 0.3 h equals 2. If I take the natural log of 2, that will give me 0.3 h. The natural log of 2 is 0.693. Shout it out from the back if I got that wrong. I think that's right. Following my key here. These keys are posted too. If you don't like listening to me, you just want to look what I wrote, you can do that too. All right. So 0.3, divide both sides by 0.3, and we have h equals 2.3. Rounded to 2 decimal places. So how many hours? In 2.31 hours, bacteria will be 18,000. There's probably better ways to say that with a sentence, but we'll stick with that one. You know what? I'm not feeling blue. I'm feeling green. So let's try green for this next one. I keep looking at the clock because I'm filming this during parent-teacher conferences. Hi, parents, if you're in my hall. Okay, between what two whole numbers is log 550? Explain how you know. Okay, so again, this is an example. If you just write what the answer is here, like if you, the more exact your answer is, it's kind of like you're not reading what the question is asking. The question is asking for us to explain what the numbers should be in between. Okay, so what do I mean by that? Well, 5 to the power of 1 is 5. Okay, 5 to the power of 2 is 25. And a little hint here, 5 to the power of 3 is 125. Now, I wrote these because if I were to actually use logs and rearrange these like the logarithmic way of writing this. So I would say, okay, log base 5, argument 5 equals 1. Log base 5, argument 25 is 2. And here, log base 5, argument 125 is 3. So the question at hand is log base 550. Notice where I put this in the exponential chart here. It's in between 2 and 3. I know that if I go 5 to the power of 2, I'll get 25. That's too low. That's below 50. If I go 5 to the power of 3, 125. I'll go too high. That's 125. 50 is a little closer to 25 than it is to 125. So I'm going to estimate. I don't know, let's say 2.3-ish. Okay, that's closer to 2. It is between 2 and 3. So what I would say here is that you are saying that log 550 will be between 2 and 3 because log 5 of 25 is below log 550 and log, well, I should say, maybe let's use the exponents. 5 to the power of 2 is 25, which is below 50. And 5 to the power of 3 is 125, which is above 50. So it stands to reason that 5 to the power of something in between 2 and 3 will get to a number in between 25 and 125. I estimated it at 2.3. You could check your calculator to see what the actual one is, or you could just put 2.5 to the power of 2.3, see if it's close to 50. It's not, maybe lower it or higher it, depending on what your answer is. All right. Move that graph over a little bit. Okay, so if we're looking at this, we have bacteria A is represented with bacteria A is the blue. How do I know that? Because bacteria A has a higher starting point. Bacteria B is the green because it has a lower starting point. Okay. When will bacteria A cover 300 square millimeters? Don't just look to the graph for this. This is asking for an exact thing, so you should be solving. So 300 equals 24 times E to the power of 0.4 H. Okay. Divide by 24. But speaking of the graph, if you used your graph, you could go up to about 300 and go over to A. And I'm guessing my answer is going to be somewhere close to 6, right? If I do all this work and my answer is like 126, something went wrong, or if it's really low, right? So I'm estimating this is going to be close to 6 based on the graph. Divide by 24, I get 12.5. Should have done this in blue because we're talking about population A. We have E to the power of 0.4 H. Okay. So that means now I will do natural log of 12.5 is going to equal 0.4 H. Natural log of 12.5 was 2.53. Divide that by 0.4. And I get, drum roll, 6.3 3, 1, which is close to 6, like we said. Okay. Approximate coordinates of the point of intersection of the two graphs. Right here. When I first did this, I wasn't loving this graph, but then I realized, maybe my line just wasn't that straight. So I went down and I was like, you know what? Roughly, I don't know, 5.2, 5.2 hours. So what would that say? That means in 5.2 hours, both bacteria are about 220 millimeters squared. Okay, and that's a good estimate based on the graph. We can look at that. That's when they're even. That's when B surpasses A, or after that is when B will surpass A, right? But, oh, last year's version, I guess we didn't have to find the exact coordinates. So we'll get to this merge discussion, I promise. So exact coordinates. Oh no, get out of here. All right. Pause for technical difficulties. The annotate button is right by the go back button. Okay, we don't have room on this. So, okay, we're going to do letter C on the merge discussion page. Okay, so letter C, I'm reading it off my page, the exact coordinates of the point of intersection of the two graphs. So basically, you're taking the two equations, right? You're saying when is 24 times e to the power of 0.4h the same as 8 times e 0.6 to the power of h. Okay, these aren't necessarily easy, but they go about the same processes that you have. I want to get rid of this 8. So I'm going to divide both sides by 8. Why did I pick the 8? Because 8 goes into 24. Makes it easier. Okay, so now we have 3 times e to the power of 0.4h. And this is the part that will throw most people off. Got e's on both sides. Some people want to just subtract it from both sides. We got to realize 3 is being multiplied by that. So I'm actually going to divide this side by e times 0.4h. Do that on both sides. E and E cancel out. That's ironically easy enough, even though we're dealing with some weird letters there. And then rule of exponents, we should subtract the numerator from the denominator from the numerator. So 0.6 minus 0.4, that gives me, now we have E is 0.2h equals 3, right? And what we're doing here, now we just have a natural log problem to figure out. And again, we want our answer to be somewhere close to like 5.2, right? We already used our graph to help us estimate that. So the natural log of 3 is going to be equal to 0.2h. And we get natural log of 3 was 1.098.2h. Divide both sides by 0.2. And I think it was 5.49306, something like that. The reason I'm going to far decimals here, because I want to plug that in when it says, what is the point of intersection in 5.49306 years, right? So roughly not years, sorry, hours, both populations, and I put it into the calculator to get an exact amount. We said a roughly, what was our estimate? 220. When I put it in, it actually found out that it was, did I put my exact amount? It was roughly 216 millimeters. All right. Oh, now the arrow works. Okay, so on to here now using these log charts. I gotta be honest, these are easy points. Go to where 60 is. There's your answer. A. Go to where 20 is. There's your answer. For B. C. Go to where 22 is on the log base 2. D. Well, don't circle it there. Circle it here. Label D. So like we could put equals 4.7549. If you don't use the chart and use your calculator, you can just find those values in there. That works. Okay, so as promised, merch discussion. I know it's why most of you stuck around. Okay, so I was informed today that merch is kind of like a slang that means like on God, or, yeah, I would put that as truth. My explanation of this slang is like, well, when I hear merch, I think merchandise. So I did a little bit of research, as you should do with slang words, right? See where they come from. So I found out, yeah, it's like saying, okay, on my mama, merch. I'm going to do well on that test, merch. Okay. Now, and then what I found was it says, yeah, put something on it. And that went in my head. And I was thinking, okay, well, if I were selling merchandise, doesn't that mean I would take my logo and put it on something? Like here, like Red Pants Thursday, right? That's merch for Red Pants Thursday. So I put it on something, just like if I'm saying I'm going to get an A on this test, merch, saying I'm putting that on God, I'm going to do well on the test. Anyway, discussions such as these are what really, truly are going to lead to greater math students, right? Okay, do great, check your reviews. Where do I go to stop the recording? Singing what I'm thinking. Bye, everyone.